everyone, my name is Mahreen Chowdhury, and today I will be presenting the first lab in Physics 2212, charge tapes. So what is this lab about? The main purpose of this lab is to observe the interactions that occur between two electrically charged pieces of tape, and from these interactions, we want to determine how much excess charge has accumulated on each of these tapes. The materials we will use in this experiment is a roll of clear tape, a ruler or meter stick, a flat surface, two stackable objects for support, and glow script to develop the computational model to stimulate the tape and interacting forces. So for the results, we will find that the charge on each tape was determined to be 4.67 times 10 to the power of negative 9, and the number of electrons lost by each tape was determined to be 2.92 times 10 to the power of 10. Here are some fundamental physics principles we need to know for this experiment. Newton's second law states that the change in momentum is proportional to the net force applied to it, or in similar terms, force is equal to mass times acceleration. Secondly, Coulomb's law describes the force of attraction between two electrically charged objects, and Newton's law of universal gravitational force describes the attractive force between any two objects that have a mass. So the experiment procedure, we first created what we call a U-tape, and we did this by placing one tape on a flat surface like a table, and we placed a second piece of tape directly on top of that, and then quickly ripped the top U-tape off the base tape, leaving the base tape on the table. And this action is what creates the charge on the U-tape. Once the U-tape was prepared, we observed how it interacted with a variety of objects. We tested its interactions with hand, a second U-tape, a charged object, and an uncharged object. These observations helped us determine the type of charge on our U-tapes. Then we conducted the main part of the experiment. We suspended one U-tape on two objects of equal height and carefully placed a second U-tape directly underneath the suspended one and observed their interaction. So now let's discuss the observations we made during the experiment. So we observed the interaction between two U-tapes and they consistently repelled. And this is a fundamental principle in electrostatics where like charges repel. Next, we examined the interaction between a U-tape and a neutral object. We observed an interaction between the charged tape and the marker, and this phenomenon occurs due to polarization. Similarly, we found an attraction between the U-tape and a hand. This is also an example of polarization. Our hands appear neutral and are conductive enough for the charged tape to induce a charge separation. And this is why minimizing handling is so important because it can transfer charges and induce unwanted polarization effects. We knew that this plastic pen was negatively charged. So when we brought the U-tape near this negatively charged pen, we observed that the U-tape must be positively charged. Initial conditions, so the tape mass was 2 times 10 to the power negative 4 kilograms. The tape length was zero point 0.2 meters. The tape width was 0.02 meters. The tape area was 0.004 meters square. The atom area was 1 times 10 to the power of 20 meters square. And the number of atoms resulted in 4 times 10 to the power of 17. In this model, tape B was my system, and then tape A and everything else was a surrounding. The distance between that system and surroundings was found to be zero point 0.01 meters. Now, the main objective of this lab was to calculate the amount of electrons that were removed from the positively charged piece of tape. First, we found that the gravitational force is 1.96 times 10 to the power negative 3 newtons, and then the electric force was also 1.96 times 10 to the power negative 3 newtons. Electric charge comes out to be 4.67 times 10 to the power negative 9 coulombs. By taking the charge of the tape and dividing it by the absolute value of the charge of an electron, we can determine that there were exactly 2.92 times 10 to the power of 10 electrons that were lost. Here is the computational model in the glow script that serves as an ideal representation of the experimental procedure that just occurred. You can see that the charge of the piece of tape and the ratio were able to be accurately calculated in our model. We had to make a few assumptions to make the computation more bearable, and this included assuming that the tapes had the same net charge. It also assumed that the charge of each piece of tape were located at a single point in the center, and that the long piece of tape could be treated as a point charge. But we know that these assumptions would of course cause some errors throughout the actual experimentation because we know that there's going to be an unequal distribution of charges on each tape, as well as there's going to be loss of charge due to handling or just the external environment. Now on to our discussion. What if electrons had positive charge and protons had negative charge? What would change about the observations you had made with your tapes and other charged objects? The field of objects or the directions could reverse, but other than that, nothing changes, and all the observations made throughout the lab remain exactly the same. Although the charged piece of tape would now be considered negatively charged. They will still repel each other, and this is because like charges always repel. Why is it important to handle the charge tapes as little as possible? What happens when the charge tapes come into contact with your hands or other objects? The charge tapes begin to neutralize when they come into contact with our hands. This is because they're trying to gain back those electrons that the tapes lost due to contact with human hands. And in the process, the charge is transferring to our hands and decreasing the overall positive charge of the tape.